So here we're given that S is the set of all positive integers n such that n squared is a multiple of both 24 and 108, which means n squared is 24 times something, and it's also 108 times something. So the best way to think about these problems is to do the prime factorization and see what it reveals about n. So 24 is 8 times 3, and 8 is 2 cubed. So I know n squared has to have a 2 cube, a 3, and some other things. And then for it to be divisible by 108, I have to do the prime factorization of 108. Divisible by 9, 12, 3 squared, 4 and 3, that's 2 and 2. So that means 2 squared times 3 cubed times something. So I know that n squared has to have a 2 cube, and this says 2 squared. So I know for sure n squared must have 2 cube. And for it to be a multiple 108, I need to have 3 cube. So this number is actually the least common multiple of both 24 and 108. And I need to have some other things. But if you notice here, these are both odd. I need n to be an integer, which means that this additional piece, at the very least, is going to have a single 2 and a single 3. There could be other things, a square, you can call it m squared. But at the very least, you need a single 2 and a single 3, because otherwise n would not be an integer if there were no other 2's and 3's. Which means that n squared has a form 2 to the 4 times 3 to the 4 times some other integer m squared. This could be 1 or it could be anything. Which means n has to have a form 2 squared times 3 squared times m. And that number is 4 times 9 is 36. Which means, based on what's given here, n must be a multiple of 36. And the question is asking which of the following integers are divisors of n. And 12 will always divide a number that's a multiple of 36, so A works. B doesn't work because 24 doesn't have to be. It could, depending on what m is, so B is out. And C also works because that's 36 times some number will always be a multiple of 36. And D, 72, again, doesn't have to be. So the correct answer is A and C, 12 and 36.